Hi guys, so in this video, what we're going to do is basically just do a bunch of factoring. So the whole point of lesson 6 is to take all the different types of factoring that we've learned and apply them all at once. So actually the main goal of this lesson is to know which factoring method to apply. Okay, and so in order, let's just go over all the different kinds of factoring that we've learned. So greatest common factoring, factoring by grouping. So this is usually where we have 4 terms. We learned special products, which we're going to go over a bit more in depth in lesson 1.7. So we're actually kind of skipping this at the moment. And we know that we factor trinomials of the form x squared plus bx plus c into x plus m x plus n, where m times n equals c, and m plus n equals b. And lastly, we learned how to factor trinomials of the form ax squared plus bx plus c, and it's not just a simple x plus m x plus n. What we have to do is break up the middle term, the bx term, and we do that by multiplying a times c and figuring out the factors of a times c, and that's how we break up the middle term. So I'm just going to do a bunch of examples here. So in a minute, I'm actually going to turn my mic off, and what I want you guys to do is try all of these questions, and if you can't get them, you can look at the answers, you can watch them in this video, or you can just click on our class notes document and look at the answers there, okay? But before I just go and do a bunch of factoring, what I'd like you to do, and obviously I want you to try these questions before you just watch me do them, because otherwise you won't get anything out of them. But what I want you to do is take a look at this flowchart that I made. So this should help you figure out what factoring method to apply. So you're going to get a question, and it is going to be a polynomial, and you're going to be asked to factor it. The first thing you should always do is check to see if there's a GCF, and if there is, you factor that out. Then, whatever you have left over, you should look at the number of terms, because if there are 2 terms, chances are it's a difference of squares. So you can check to see if it's a difference of squares, and if it is, you can use the formula that we know, a squared minus b squared is a plus b, a minus b. Okay? Now, if there are 4 terms, we'll go here next. If there are 4 terms, chances are you're going to have to group in 2s, meaning you would have, 2x plus xy minus 5, 10 x squared minus x squared y. Okay, so 5x squared y. So if you had that, you would group the first 2 and last 2, you'd factor out a GCF, and then factor again. You can mostly ignore, or you can ignore this root. We aren't going to be seeing that this year, so don't worry about that. If you have 4 more terms, you're going to group in 2 and 2, and then GCF twice and factor. Now, where we really have to think about it is if I have 3 terms. So if I have 3 terms, I have one of 3 possibilities. The easiest one is if I'm given the form x squared plus bx plus c, then I can factor into x plus m, x plus n. Or I could have ax squared plus bx plus c. And if that's the case, then I have to do what I just said. I have to break up the middle term by using factors of a times c. That's called decomposition. Now, I actually can factor all perfect square trinomials under those 2 flowchart paths, but it's still good to know what a perfect square trinomial is. Okay, so if it has one of these 2 forms, and I can see that, it's really simply going to factor into a minus b squared or a plus b squared. Okay, so for example, let me just do a couple with you. So the first one, I have 3 terms. I'm going to factor out a GCF. Which actually is just 3. And I can see that this does not fall into any of the trinomials that we know, so I'm done. I'm going to do the same thing here. So my GCF here is going to be 8xy. And I cannot factor that any further. For 3, I'm going to notice that there's a GCF of m minus 2 in both of these. And then I'm going to simplify this bracket. All right, so for number 4, I have a case where I have 4 terms. And I can see that if I group the first 2 and last 2, it actually doesn't work out very nicely. There's no GCF. So I'm going to rearrange it, and I'm just going to try rearranging by putting the A's together and putting the 3's together. All right, what happens now? And actually, guys, x plus y and y plus x are exactly the same. So I can factor out x plus y, a minus 3. Great. So I'm going to try to factor these. The GCF of the first 2 is x cubed. All right, now I can see negative x squared plus 2 is pretty close to x squared minus 2. Yeah, if I factor out a negative, it's going to work. All right, next. So we're going to group again. So I notice here that I actually made a mistake. And the reason I know I made a mistake is I can still factor a z out of that last bracket. And I'm just going to put it at the front because it looks better there. But really what I should have done right from the get-go, if I were to do this properly, I'll do it in red. I should have factored the z out first. And then I can group these 2 within that. All right, either way we get the same answer. Okay, so this next one, 2 numbers such that m and n such that multiply to negative 32 and add to negative 4. That's going to be x minus 8, x plus 4. All right, let's look for a GCF. Okay, I think I can factor this further. Are there 2 numbers that multiply to 14 that add to 9? Yep, 2 and 7. All right, for these ones, this is in the form of ax squared plus bx plus c. I multiply 2 times 4 to get 8. I write out the factors of 8. And I can see that the one that adds to 9 is this one. So I'm going to break up that middle term. And then I'm going to use grouping. I know I've done it right because those two are the same. All right, similar deal here. What are the factors of negative 24? The ones that add to negative 5, well, what do I have here? 12 and 2. I have negative 8 and positive 3. That's the one. All right, this one, we're going to skip this one for now. This is actually a perfect square trinomial, positive, and I thought I took it out. We can still do it actually, but the numbers are going to be big. So what is 16 times 9? So we're going to get 144, and we can see that the two numbers are going to be 12 and 12. 12xy plus 12xy. So I'm going to group. I'm going to see that, yes, indeed, this is a perfect square trinomial. And I can write it like this. All right. Number 12 is same deal. If I look closely, I can see this is a perfect square trinomial negative, but that's okay. We can just do it this way. And we can see that this is actually 18, negative 18 times negative 18. I'm actually going to put this here. Okay, so this is 81x squared minus 18x minus 18x plus 4. All right, for this one, we can factor out 5z. And we need two numbers here that multiply to 1 and add to negative 2. All right. Here we can also factor out a GCF, 20x. We need two numbers that multiply to 6 and add to negative 5. Great. Okay, let's look at the next one. If we take a GCF, we can see okay, and then within this bracket, we will group. Alrighty. I think we've got another GCF here. Okay, and again, we've got a very similar one. I think we can actually take a GCF first, which is going to be 2x squared y. All right. All right, and here we can GCF. Okay, so what is the GCF here? We have two terms. Okay, so I'm going to look at the numbers first so I can see the GCF between 25 and 100 is 25. The GCF between x minus 4 to the power of 4 and x minus 4 to the power of 3 is x minus 4 to the power of 3. And then lastly, I've got x plus 3 to the power of 3. Now, what goes in this bracket? Well, I can see I have x minus 4 to the power of 1, because x minus 4 to the power of 3 times x minus 4 to the power of 1, I would add the exponents to get this 4. Okay, and now I'm going to subtract, and 25 goes into 100 4 times, so it's going to be minus 4. And I have x plus 3 to the power of 1. Now we know we actually don't have to write in the powers of 1, so I'm going to cross them out, and then I'm going to erase them. We don't need those. And now what I want to do, my answer should always be as simplified as possible. Okay, so in here, I'm going to get x minus 4, and then I have to distribute the negative 4. So I'm going to get minus 4x minus 12. And then when I simplify this, I have minus 3x minus 16. Okay, so this is fine, but most people don't like having a negative in here like this. So what I can do is factor out the negative 1 from the last bracket, and I'm left with 3x plus 16. That just tends to look a lot nicer. Okay, just make sure that this one is positive, because the negative that we put in front here came from factoring out from this negative and this negative. All right, guys, that's it. I know there are a lot of questions there. Hopefully you worked through them. Your homework is to do 1.6